The EU has challenges in building chemical plants in Europe, and certainly the UK has the same problem, and the UK chemical industry has been in decline. As to whether or not the UK and the EU SAF mandates will help SAF innovation, they will, but they may not result in plants being built in those places. They will be built elsewhere, perhaps in Asia, and then the fuel imported.
Good morning, ladies and gentlemen. We are back with yet another episode of Interviews with Experts. Today I am speaking with Mr. Andrew Symes, CEO and founder of OXCCU. OXCCU spun off from the University of Oxford in 2021. Today, they've just announced Series B funding of $28 million.
Welcome, Mr. Symes, and congratulations.
Thank you. Thank you for having me.
Could you tell us a little bit more about the funding round and how do you plan to expand this investment?
Yeah, great. Pleasure to be here. As you said, my name's Andrew Symes. I'm CEO and co-founder of OXCCU. Spin out from Oxford University, focused on sustainable aviation fuel. Today's big day. We've announced our $28 million Series B, and the purpose of that is to essentially build our second demonstration plant, scale our facilities in Oxford Airport, and accelerate our commercialization so we can get a commercial SAF plant in operation by the end of this decade.
Where is the second plant?
The second plant's going to be next to our first plant. So the first plant was built on Oxford Airport. The second one will be next to it. We've got about 7 times the space though, so we're expanding quite rapidly. Also expand our lab facilities, and as I said, the key thing also at the same time is to accelerate the commercialization so that we're ready to get this fuel to market as soon as possible.
Right. Yes, I read you are going to expand your facility from 1 liters currently to 30 liters. That is 30 times more. So
that sounds well, but not just that. It's also far more integrated. It's going to demonstrate the full process. So it's going to essentially have an overall yield that'll be far superior.
Right. So, Mr. Symes, tell me, among your peer SAF companies, how does OXCCU differentiate itself?
Key thing that we have, so we are a Fischer Tropsch catalyst and process company, but the key thing that we have that is unique is essentially the ability to directly convert carbon dioxide as well as carbon monoxide into specifically the jet fuel range. So other Fischer Tropsch technologies will convert carbon monoxide only, and often they will overshoot, so making much heavier fuels like diesel or wax. So it's the two things. It's the ability to convert CO2 as well as CO, carbon dioxide as well as carbon monoxide, and it's essentially that selectivity towards the jet fuel range directly, so we don't have to do further steps to convert the products of the Fischer Tropsch.
All right. How is, in layman terms, please make me understand, how is Fischer Tropsch different from other processes like ATJ or HEFA for that matter?
They're all fairly different. So if we start with the one that's mainly used today, HEFA, that's really where you're starting with waste oils. Used cooking oil, it's called. It could be rapeseed oil or soybean oil or palm oil, but essentially it's been used, and then essentially it's slightly too heavy for jet fuel. ATJ is actually 2 quite different things. One is ethanol. So ethanol is currently used as a feedstock for gasoline to improve the octane of gasoline, and you could convert ethanol to ethylene, and then ethylene would undergo oligomerization, although it's fairly tricky to get that specifically just in the jet fuel range, but that's possible. But both those 2 routes, essentially going via ethanol and via the used cooking oil, essentially use crops. Neither of them are scalable in the way that people would like, because ultimately they are not true waste feedstocks. The key point is, though, is when you go via genuine waste feedstocks, those that are high in cellulose and lignin, you generally always go via carbon dioxide, and hydrogen. and then you have a choice about what catalyst you use to convert them. And what we are showing with our catalyst is that we can directly convert that feedstock, the carbon dioxide, carbon monoxide, and hydrogen, straight through to the jet fuel range, and that is far simpler than if you go, say, via methanol. If you do conventional Fischer-Tropsch, you can't use the CO2 in the stream, but the key to it is essentially the direct conversion of CO2 and CO plus hydrogen into sustainable aviation fuel range hydrocarbons, and that's a breakthrough because it's got less steps and essentially higher selectivity, which basically means less capex, less opex, and a lower cost SAF.
So what you're basically using is an upgraded version of Fischer-Tropsch.
It's an upgraded version of Fischer-Tropsch, and actually similar iron Fischer-Tropsch catalysts were used for coal to liquids a long time ago. Iron FT is still used actually in South Africa and in China, but they aren't really focused on making jet fuel range. So it's not dissimilar to a process that has been used for a long time, and that gives us the scalability actually compared to other technology routes that are far newer.
So your CO2 to fuel technology, what are the other industries that you can use it except for aviation?
Well, when we think in the future, we need hydrocarbons for three main sectors: aviation fuel, but then also chemicals and plastics. So you have to have carbon and hydrogen in the molecules for chemicals and plastics. And so, we produce naphtha as a byproduct of our process, and that can go into steam crackers and make chemicals and plastics. So, it's absolutely possible for us to start thinking as well about not just decarbonising or reducing the emissions, or perhaps not decarbonising, because we're not removing the carbon here. We've still got carbon, but we're removing the carbon emissions associated with it, but of chemicals and plastics as well. Because ultimately, if you have the ability to be able to then make a plastic out of this waste, it could be biomass waste or CO2, if it then is burnt in a waste incinerator, at that point then it goes back to CO2, so you do have some circularity.
All right. And which of these sectors do you think can realistically adopt your technology as soon as possible?
The focus for everyone, to be honest, is sustainable aviation fuel because of the price. So that's the kind of driver of the economics, if you like, and we're focused on optimizing the catalyst to get the highest amount of jet fuel yield. You could, tweak it to get higher amounts of naphtha or gasoline range, or even make more light olefins. But at the moment, the economics drive us towards making maximum SAF.
So your process heavily relies on CO2 as a feedstock for SAF, right? So with the carbon capture storage units that are coming up, can that CO2 be used to essentially make SAF?
The answer depends on the regulation. In the UK, the answer is probably yes. And in the EU, it's probably yes until 2041, after which they want you to use biogenic, and probably likely to be accepted in other countries outside the EU, but we're waiting to get clarity on that. And the argument to use industrial or fossil CO2 is that essentially it's displacing fossil fuels. It's not perfect because you're not completely circular. It hasn't come from the air, it's come from the ground. But you're getting two uses out of the carbon before it goes to the atmosphere. And that's better than one. And it is going to reduce fossil fuel demand by doing so. And you only need a small amount of the CO2 to be converted to do a significant chunk of aviation. So I don't necessarily see it as in conflict with carbon capture and storage, because you probably need both, and actually you're only looking at a small amount of the total CO2 that could be sequestered that could supply a large amount of aviation.
If you do have an issue with that CO2 being not as pure, if I'm correct, right?
The best sources of CO2 are ethanol plants, ammonia plants, and also CO2 from natural gas processing. because the CO2 is very high concentration, and then cement is also probably a pretty good source as well, albeit it's potentially not always continuous and may have some impurities in. So certainly the post-combustion CO2 is not particularly attractive, because that's going to be very expensive to get up to 100% purity.
So your OX gas technology uses electricity for gasification process. It's not essentially considered green. So how sustainable is that pathway?
Well, in all chemical processes, once you start to electrify them, you are going to have some benefits. The benefit will be higher depending on how green the electricity is. But generally, as long as it is fairly green, there will be a significant benefit, because the other alternative is essentially burning natural gas or maybe coal to power that process. So yes, you're right, you don't want to do this in a place where you've got huge amounts of coal electricity or gas electricity, but as long as you're on the journey towards a decarbonised grid, and you've got a reasonably low carbon intensity grid, or maybe you've got your own renewables nearby that helps, then there will be a significant benefit versus the alternative, which is to power the gasifier via burning your feedstock, or by burning coal, or by burning gas.
So your technology is only scalable for places where there's abundant renewable energy available?
No, that's not true. Depends on the feedstock. Say if you take biogas to SAF as an example, you need some electricity for the process, for the reforming, but you don't need that much compared to some of the other routes. So you wouldn't, if you use biogas as feedstock, you wouldn't need a particularly green grid, for example.
All right. So from an operator's point of view, how do I pick which SAF to choose? Or are there any, or are the different SAF pathways that I can, choose alternatively?
Realistically, all these processes are producing blending components, realistically, and then these blending components get blended together to make a SAF. And from an airline operator perspective, you don't notice any difference. The Jet A1 spec remains the Jet A1 spec. You receive Jet A1 fuel, so you don't really need to worry. But the blender and the fuel suppliers do, because they need to supply an on-spec jet, and you also have to ensure that the components comply with ASTM. So ASTM is an additional safety check to ensure that each of the blending components meets their specification as well, or a certain specification, or goes via a certain route.
So in recent times, we have heard a lot of news about retro gas fitting designs being available for shipping industry. Basically, if it's an LNG carrier, there are just retrofit designs that can seamlessly make it into an ammonia carrier. If there are going to be retrofit designs for the aircrafts, will they be necessary once you go to 100% SAF?
Got it. Okay. No, it stays the same. So we'll keep the same engines, same aircraft that everyone's happy with, and we'll just burn SAF instead of Jet A1, but we really won't notice any difference. It will be Jet A1, it just won't be fossil Jet A1.
Let's talk about demand for SAF a little bit. So global SAF demand is projected to fall short of 23 million tons by 2035. From your perspective, what are the most prominent factors that will drive this gap?
Yeah, it's enormous. Today we make 0.1 billion litres, and I think we have to make around 500 billion litres by 2050. So the gap is massive, and it's going to get bigger as the mandates come in. The big issue is actually the feedstock, but also the technology to convert the feedstock cost effectively with low emissions. The big issue in SAF is essentially being able to make cost effective low carbon SAF from genuine waste feedstocks. So if you unpick each of those things, Genuine waste means you've got to start using the high lignin, high cellulose waste materials and CO2, because they are the key waste feedstocks that we have available. We can't just use oil or starch-based ethanol. Low carbon intensity. In order to get a good carbon intensity, you've got to start converting the CO2 in these processes as well, not just throwing it away. Otherwise, it's very wasteful. And low cost, we've got to actually think about the technology routes here and reduce the number of steps and make them simpler, so that essentially we get straight to the jet fuel quicker with less capex and with high selectivity, so less OPEX. So it's all of those essentially, but basically technology is very important to all of it. Feedstock is the next and most important. So it's a combination of technology and feedstock.
So all of the factors that you mentioned, which of these do you think will the industry be able to solve the fastest, the quickest?
Well, they both need to be solved at the same pace, realistically, because you need both. You can't just have one or the other. Once we have solved technology and feedstock, then the other issues will be easy. So the financing, the regulation, etc. Because once you have SAF that's made from genuine waste that's, let's say, 2 times more expensive than fossil fuel, that's a mass market product that everyone will buy. The issue is if you're, say, 5 to 10 times more expensive than fossil fuel, it's very difficult to finance it and to get politicians and regulators behind it. So you have to get it down to 2 times the fossil fuel price, or roughly around that level, and from genuine waste feedstock. So yeah, that's the key challenge, and the key to that is basically new technologies that can convert that feedstock and get that price down.
Interesting. So you spoke about regulations. EU has one of the world's most stringent policies around aviation fuel. UK SAF mandate that was just announced last year. Do you think this UK SAF mandate will be one of the most stringent? How do you think will that affect the industry?
I think Refuel EU is fairly stringent, but we need to wait and see what the buyout prices are. I think it is a big piece of regulation that will have a big effect. I think it's very important to send that signal to the industry that aviation needs a solution and that we need to start now, because if we wait too long, then we won't have it, when we want to scale up to much larger percentages. So we've got to start somewhere now and start scaling these technologies. It's worth saying though, it's not just about the EU. As you said here, the UK has also got its own SAF mandate. India have announced a SAF mandate. Singapore are talking about SAF as well. Different kind of mechanism, but still. And then we're waiting to see whether China will step in with one maybe next year. So it's not just about the EU. I think this is a global market. The key to it though actually is not just about the regulation, but it's about the technologies, because we need, as I said before, we need these technologies to get the price of SAF down, and then all countries will start mandating a certain amount of SAF. It becomes very easy for them all to do it.
So you don't think these mandates or these regulations, they will hamper innovation and technology?
No, they help with innovation and technology, because if you don't have any demand, then there will be no demand for new technologies. I think what you're alluding to maybe is the EU has challenges in building plants and chemical plants in Europe. I think that's a separate question. And certainly the UK has the same problem, and the UK chemical industry has been in decline. That's actually a separate question. There's different issues there as to whether or not the UK and the EU SAF mandates will help SAF innovation. They will, but they may not result in plants being built in those places. They will be built elsewhere, perhaps in Asia. And then the fuel imported.
What is one major challenge, if you had to solve today, what is one major challenge in the SAF industry that you would want to solve ASAP?
I think we're solving the most important challenge in it, which is how do you directly convert the carbon dioxide in these gaseous waste carbon streams into jet fuel? Because once we do that, it will have a big effect on the overall cost, and it will open up the availability of the amount of feedstocks we can work with. And so suddenly then you've solved both of the issues, and that's really what I think we are doing, and that's why I think we've kind of got the funding and the attention of the industry.
Yep. So how do you envision the aviation industry in the next 10 years?
Well, it will start small with SAF. We're talking about 1 to 5% over the next couple of years. But the point is that you've got to start somewhere, and then once we get that, we then scale. And as long as we're focused on these genuine waste feedstocks, there's no real limits because of the amount of CO2, the amount of wood waste in certain countries that's genuine waste, the amount of straws that certain countries make that currently just get burnt, the amount of farms that produce to farm waste that currently may go to methane naturally and cause warming, but now then could be turned into biogas and put into the grid and then taken out of the grid to then convert into SAF. There's huge amounts of potential, but it will start small. And I understand that people will be a bit like, oh God, this is tiny to start with, but you've got to start somewhere. The wind and the solar industry started small, and now they're pretty big industries. And I think SAF will be the same. And it ultimately represents the future for the whole petrochemical sector. And that includes plastics and chemicals, as mentioned before. So this is bigger than just SAF, really. This is about how future generations can get hydrocarbons, but without the carbon intensity, because they will need hydrocarbons. You can't just eliminate all of them in a net zero world. It's not all just electrification. It is also about how you source sustainable carbon.
Yep. Right. So I know your second plant is on the way, but apart from that, what is next for OXCCU?
Well, the key thing is to get OX2, our next demo plant, up and running as soon as possible. So we're going to aim to try and get that up and running by the end of next year. It's going to be pretty tight, but I think we can do it. The next thing will be to build out our commercial scale-up plan as well, so we can start working on where our next plant's going to be, and that will be producing very significant volumes then of fuel. So we've got to get on and do this as soon as possible, and then also simultaneously focus on that next first of a kind plant.
So that plant, like you said, it's not going to be in UK or Europe, is it?
Well, it could be. We're looking at sites there, but yeah, that'll be the subject of future announcements. So yeah, stay tuned.
Of course. Thank you, Mr. Symes. It was lovely chatting with you today. I hope you had fun.
It was a pleasure. They've been very good questions. Thank you very much.
Thank you so much. Have a good day. Bye-bye.
Bye.